Mike, you will not have to remember the formulas. I'm going to put the formulas on the test so that you will be able to refer to it. Let's say we want to use the one of the difference of cubes. We want to do a difference of cubes, which means I'm going to use this formula right here. Okay, I'm going to write that formula. A cubed minus B cubed equals to A minus B times parentheses. Again, you do not have to remember this because I'm going to give you a formula chart on the test. So if you have a difference of cubes, this is how you're going to factor a difference of cubes. So we have, the problem is 8c cubed minus 125d cubed. We want to factor that. Now, we don't have to worry about the c and d. They are obviously cubed. Okay. What about 8? 8 is the cube of 2, and 125 is the cube of 5. So that means, what am I cubing here? I'm cubing 2c. That's going to be my a value because that's what I'm cubing to get 8c cubed. And so what am I cubing to get 125d cubed? I'm obviously cubing 5, and I got to have a d in there. So that means A is my 2c, and B is my 5d. So that just fill in the formula and we're done with this problem. Okay. So, and I'm going to actually do this in green because we're going to go right to them. So that means 8c cubed minus 125d cubed is equal to, first of all, a minus b. That's 2c minus 5d. That's a minus b. Now I got to figure out what a squared is. Parentheses, a squared is. Well, if a is 2c, then that means a squared is 2c squared, which is 4c to the power of 2. That's what it is. So that's going to be 4c to the power of 2. Again, I should have made that green. So I'm going to make that green. 4c to the power of 2. Plus, whatever a times b is. Well, a is 2c. So AB is 2c times 5d. That's going to be a 10cd. So that's going to give me a 10cd plus, and let's see what else. I need b squared. So if b is equal to 5d, then b squared is going to be equal to 25d squared. And so 25, and I got to move this out the way so you guys see. Oops. All right. 25d squared. And that's holding my parentheses. And that is our solution. Okay. Of course, if you had a sum of cubes, you would use the sum formula. Okay. If you had a sum formula, if you're using the sum of cubes, then you would use the sum formula. So that was the first part of the lesson. Okay. All right. Oops, I don't want to do that. Now let's look at the second part of the lesson. I told you it was a short video. All right. The next part of the lesson. Oops. Let's see. I don't believe I need this anymore. Let's see. Factoring by grouping. Okay. All right, and we're going to follow these steps in order to do that. We're going to do that out. Okay. Oops. All right. So let's say to factor completely, x cubed, change the code, x cubed plus 5x squared minus 2x minus 10. I'm going to factor that completely. So the first step we want to do is we want to group the two to find the GCF. So we're going to look at this in twos. That's what we'll look at in twos. So I'm looking at, I want to know, to find the GCF, I want to know what does x cubed and 5x squared have in common. Let's go to our thought here. So I got x cubed is written like this. And actually, red is a very cool source for what I want to do. X cubed is equal to x times x times x. What about 5x cubed? 5x squared, sorry, not cubed, is 5 times x times x. I want you to notice what they have in common. They both have two x's in common. So this is your GCF. So your GCF is x squared. So I'm going to take the x squared and I'm going to factor it out of these first two terms. So look it over here. I take the two x's out, or x squared, what's left? It's x. All right. I got a plus sign here. If I take the two x's, x squared out of 5x squared, what's left? That's the 5. Okay, we'll just factor. Okay, what we've just done is we have factored out the GCF. Now let's do it for the second part of the equation. Second part of the polynomial. So let's look at negative 2x, and let's look at a negative 10. And let's see, let's explode them so they have in common. Well, they're both negative. So I'm going to immediately fact, I'm going to put a negative out, which is really like -1. It'll be better if I make it -1. And then 2 times x. What about -10? Well, I could -10 if they also have a 2, 5. Yeah. So we found something that they do have in common. They both have -2 in common. That's what they have. They both have -2. So let's go ahead and factor out the -2. Okay. And let's look at what we have left when we take out the -2. Well, I have an x. Let's see. And I have a positive 5 here. Notice it's not a -5. It's a positive 5. The negative's over here. It makes the whole thing negative. So that's what you end up with. So what we've just done is we have factored out the GCF. That's it done. So the next thing we're going to do is rewrite this using the distributive property, because this is the distributive property. What do they both have? They both have x plus 5. So if we rewrite this using the distributive property, we'll actually get this. We get x squared minus 2, right? Let me see if I can clean that up. Minus 2 times x plus 5. And that is your answer. Why is that your answer? The reason why this is your answer because you can't break this down any further, okay? And you can't break this down because in order for us to factor this too will have to be a perfect square. It is not. You cannot use the perfect difference of two squares here. So you cannot factor this. So since you can't factor this term and you can't factor this anymore, you have factored complete. You have factored that complete. Okay. So what am I actually saying here? What am I actually saying? And I'm just saying this for the sake of completeness, okay? For the sake of completeness, so you can understand what we are doing here, all we're saying is that, and I have to make it smaller, what we're saying is that x cubed plus 5x squared minus 2x minus 10 is the same as x squared plus 2 times x plus 5. And of course, if you did a box method or for, you'll see that this is true. Okay. All right. So lastly, as I finish up this video, there were 2 more examples that I did. If you're taking notes, this would be a good time for you to pause the video and just basically copy this down. Okay. All right. But what the work that I'm actually going to be looking at you guys doing is going to be what the problems from slide 6 and 7, which are all cubes, and the problems from 10 to 12. That's going to be your work. Okay. All right. If you can show work, fine. If you're not able to, or if you see where you don't need to, that's fine. Except for with this, if you're doing factoring by grouping, you need to show work there. But on the factoring by cubes, sum and difference of cubes, you don't necessarily have to show work there because the formula is doing all the work there. Okay. All right. So I'm going to clear this out. And the last thing I'm going to do in this supposedly short video, okay, is I'm going to take one of your pages here and let's see. Yes, this is the one. All right. And I'm going to do one of these. Okay. All right. And actually, I think the one that's going to be the most beneficial for me to be doing is doing this. So to shorten the video, I'm just going to do this. Okay. All the rest of the practice problems I need to do. So 4x cubed minus 2x equals 4x. That's not equals, plus 1. Factor this completely. Okay. So in this particular example, I'm looking at this. I got 4x cubed, which is 4 times x times x times x. Then I got x cubed, x squared, sorry, which is x times x. So it becomes obvious that they have that in common, those in common. So I'm going to factor out the x squared, and that's going to leave me 4 left, 4x left. And then I got, it looks like I have nothing left here. But actually I do. I have 1. So 1 can always be factored out. So it's going to be minus 1, actually. Bring out my minus, and I got 1. Because if I have x squared and I divide x squared into x squared, if I take away x squared, do I have 0? No, I have 1. Okay, if I had 0, I wouldn't have had the x. So I have 1 there, that's all it's there. Now, the next thing I'm going to do is I got 4x, and I have 1. Okay, and actually I have a negative 4x. So, what do these have in common? Well, I can rewrite, if I go negative 4x, I have that. 1. Well, here's what I can do with 1. I can factor a negative out for 1 because I can write 1 as negative 1 times negative 1. So if I do that, then I can get a negative 1 out of both of these. Okay, so how does that work? If I take my negative 1 out, that's going to give me a 4x minus 1. If I take out a -1, like if I have 1 there, that'll make it a little easier to see if I do it like that. Then you can see that comes out. And you see why I have that negative there? Because at a negative comes a negative there. All right, so everything works out. So, and this 1 should have been red, so I'll just go ahead and be consistent. All right. All right, so what do we have? Let's use the distributive property and we write. So I'm going to write this as x squared minus 1 times, what do they have in common? 4x plus 4x minus 1. They have that in common. Okay. So that's the distributive property. Are we done? Can we factor this? No. Can we factor this? Yes. X squared minus 1 is a difference of 2 squares. So I can write that as x plus 1, x minus 1, and then I bring down my 4x minus 1. Once I've done that, then I am done. So those are your examples. And well, actually, another practice problem I did for you. You want to do the problems again. Slide 6 and 7. That's what you're going to do. And sorry, let me just make it more obvious. Slides, problems, practice problems. Slide 6 and 7. And 10 through 12. This is factoring by grouping, and this is factoring cubes. So cubes, all right, cubes like that, right? Cubes and group. All right, and that concludes the video.